Okay, this is the last lecture note. Actually, this is the supporting material. We have shown that I think we have discussed about the standard designing procedure. This is the way we have started to design a digital circuit. And we have, I think, understood all the steps of this basic designing procedure. We have 4 steps. First, we are drawing this type of block diagram to show number of inputs and number of outputs. And after that, we are preparing a truth table. So based on the truth table output columns, we are writing output equations. But here we have only single column. Then we write single output equation. Then for this equation, according to the equation, we draw this diagram. Okay. Then likewise that after that, I asked you to try this question. We did it in the class. And this is a little bit expansion of a previous question. And here also we draw the block diagram and we prepare the truth table. Then this was the last equation we received and we draw the circuit. Okay. The second one also we tried. This is the one, the prepared truth table. I think you may remember that the electrical control systems, it's having 3 sensors and 2 or more positions are detected. Then we have to turn on our output to 1. That was the problem, and based on that problem, we prepared this truth table, and we finally wrote this equation considering these ones. Then based on these ones, we draw the circuit. Okay, that's what so far we have discussed. Okay, the third one also we tried. This is flow rate, pressure, and temperature of a material. We are measuring those things. And based on this, we have 2 dangerous conditions. And first one is the green color one. Here, flow rate and pressure are low. When the flow rate and pressure are low, that is a one dangerous condition. We have to turn on our alarm there. And the second dangerous condition is pressure and temperature. They are high. Again, we have to turn on our alarm. I think this green color one is the first condition. The blue color one is the second condition. Finally, we add all these 4 conditions together to write the output equation for the alarm. Then we have to draw the equation. We have to draw the circuit. Okay. Okay, to get refresh, I think we can draw it. I'll draw it here. Then you can remember everything. You know that this is not a big problem. We have done this type of things earlier also. Then we have to generate FPT, and we can generate F bar, P bar, T bar also. Okay. Then just think about the first term. Then F bar, P bar, T bar, we have to make that one. We can take this one is T bar. This is F bar. And second, we try to make this second term. This is F bar, P bar, T. We can take T from that point. And here we have P bar. And this is F bar. Okay. Then third term. We need T and we need T and F bar. Okay. Finally, we need FPT T P and F. And then we can combine these four together using 4-input OR gate. And this is A. Is it okay? Any question? Okay, if you don't have any question, then we can go for another question. Actually, that is a little bit important because it's having different form. This is different from all these three questions so far we have discussed. I'll show you. This one we discussed, this first one, second one also, this third question, and this is the fourth question. Shall we try this one? Before that, try to identify what is the difference between this question and the previous three questions. But here, the first time we are trying to find a solution for multiple output circuit. This circuit is actually having multiple inputs. All these previous circuits also, they had multiple inputs, but they didn't have multiple outputs. They had only single output. But here, you can find 3 output lines are there. Then multiple inputs we have, and multiple outputs also we have. This is a first question we are trying in that kind. Okay. Shall we try to understand this one? Read this line. Okay. Then you will realize that here we have 2 inputs, that is A and B. A and B is a 2 binary digit numbers. Then you can read the last line. A and B both are single bit binary numbers. Because of that, A and B single bit binary numbers, and we have to draw this. We can draw this block diagram here. And we have 2 inputs. That is, one is A. A is a single bit number. Then because of that, A is a single line. Then B is another number. Then B. And in addition to that, we have three outputs. For what? To have this comparison. First comparison is A greater than B. Second one, A equals B. Third one, A smaller than B. Okay. Then we have to give the, depending on the number you are having, the values of these A and B lines, then you have to find these output lines. A greater than B, A equals B, and A is less than B, like that. But here I think it's good if you put a single letter here like this. Then in truth table, it's easy to write this one, and to make the equation also, this is C. Then A greater than B, you can take it as P. A equals B, Q, A less than B, R, like that. Okay. Then can you take a couple of minutes and prepare the truth table and write output equations and then try to draw the circuit? Okay. Take a couple of minutes, then I'll do it. Okay, then we can try this one. I think you have done it. Any question you found there? Okay, I'll do it for you. Then the second step is preparing a truth table. Here we have two inputs. Then we have two input columns, A and B. And we have three outputs, P, Q, R. P is A greater than B. This is A equals B. This is A smaller than B. Okay. Then we can fill this truth table. Like this. Then 0, 0. A0, B0. Then both are equal. Both are equal means here Q should be 1, P0, R0. Okay, this one A0, B1. Then that is A less than B. Then this should be 1 and this should be 0, 0. A1, B0. That is A greater than B. Here 1, 1 means A equals B. 0, 0. Okay, next step is writing equations. First equation, then we have to consider this column to write equation for P. Okay, then here how many ones are there? Only single one. Then we have equation that is A B bar. Then next one Q. Okay, this is equation P. And what about Q? And this is Q. We can write considering this one. Here we have two ones. Okay, that is A bar B bar plus AB. Third one, this one. We have to consider only that column. This is R. Okay. R. Here also we have only single one. That is A bar B. Okay. Then we can draw the circuit based on this. Then we have this A and B. The first term, sorry, we need A bar and B bar also. Then we can draw first one A bar B. Here you can see that, sorry, A B bar is B. This equation A B bar. This is A and this is P bar. Okay, this is P. P means A greater than B. Okay. Next one, we have two terms there. First one, A bar, B bar. Second term AB. You can see this one. First one A bar, B bar. Next one AB. This is A. And B. We can combine these two using 2-input OR gate. This is Q. A equals B. Okay. Third one. A bar B. This is A smaller than B. Is it okay? Then these are multiple input, multiple outputs. But the important thing you have to realize that we have to write 3 output columns considering these 3 outputs. Then we can fill the table using the conditions. Then after that, you have to write for each and every output equation. Here you have one output, second and third outputs. And this is the equation for 1, 2, and 3. Then you have here we have 3 output lines. Then you have to write 3 output equations. These are the 3 output Boolean equations for this output, the relevant outputs. Then based on these lines, these equations, we can draw the circuit. I think at the moment we have tried many type of problems. Then you have tried those things also. If you are okay with all these steps, when you consider the basic designing procedure, we have to identify the inputs and outputs. That is first step. The second one, you have to prepare the truth table. When you prepare the truth table, the meaning is that you have done 50% of your problem. The third one, you have to write output Boolean equations. If you have only single output, then you have to write a single equation. If you have multiple outputs, then you have to write output equations for each and every output column. Then final step is you have to draw the circuit according to the equations. That's all. If you are okay with all these 4 steps, the meaning is now you have become a digital circuit designer. Okay. Okay, then what is next? If you are okay with this, and if you don't have any kind of problems, the meaning is that now you can do all these things. It's up to you. If you have any kind of question, then you can tell me now. Okay. Then next step is we have to go for a little bit advanced designs, advanced problem solving. But to do that, we need to collect some other tools also. At the beginning, that you may remember that we found some kind of tools. We added all these things together to answer these type of questions, to do the digital designs. But now we are in a certain stage, but to go beyond this stage, to do this, some kind of advanced enhancements to this type of circuits, then we have to collect some other theorems, some other laws, and we should know all these. If you know all these things, then we can do better designs than this. Okay. Before that, you can take a couple of minutes and go back to your previous notes and check that all these things are okay. If you don't have, then you can have the small discussion time. It is a couple of minutes we can spend to understand all the previous things. Then we can go for the next section. Take 1 to 2 to 3 minutes and check all these notes and see whether that you are okay with all these things. Okay, then if you are okay with all these things, we can go to our next section. We are going to learn some kind of theorems and laws and some other important relationships. The first one we are going to learn is commutative law. This law says us it has actually two parts. The first part is for operation. It says us A plus B equals B plus A. So you may wonder that what is it necessary to tell this one? Yes, we should know that. What is this meaning? The meaning of this one is that when you take OR gate and you can give these two inputs like this using these two terminals, and you will receive output is almost same. You take the same NOT gate and interchange inputs. The same result you will receive. Okay. Again, for AND gate also, it has the same thing. The same meaning. But here I'll draw this one, but you can understand this. Okay. Then what is the simple meaning of this one? It says us order of variables. Here you can see that A plus B or B plus A. There is no difference because of that order of variables is not important. This is the idea behind this. Okay. The second one. Associative law. It says us if you take this operation and it's almost same if you do like this. It also having second part, that is for AND operation. Okay, shall we do two set of diagrams to show this one? Can you try it first? I'll draw this one. Then first one we can take 3 input OR gate. See F. But same operation, same functionality you can receive if you do this way also. You can draw for this AND operation. What is the simple idea behind this? It says us grouping of variables is not important. Okay. Then we can go for third one. Third one is associative law, distributive law. It says us you can do this expansion, and O you can take the common terms from all the variable, all the terms, and you can write it this way also. Okay. The fourth one is De Morgan's theorem. It's also having two parts. The first part is when you take this operation, that is no operation, you can have the same thing using N, but separate A bar, B bar. The second part is this is NAND operation, but you can receive the same functionality from this one. Okay. The fifth one. Principle of duality. It says us that any kind of theorem, relationship, or law, or whatever the thing is having a dual. The other phase of that. The second phase of that one, then we can obtain the second phase of that relationship or whatever the kind of theorem. The replacing all dots by plus, plus by dot, that means O by N by O. and 0 by 1 and 1, 1 by 0. Shall we write this one? Then you can understand this one well. Any theorem relationship law has a dual. How can we obtain? Obtain by replacing every occurrence of dot by plus. Plus by dot. One by 0 and 0 by 1. How can we do this one? Okay, then shall we take this this one? The De Morgan's theorem first part. The De Morgan's theorem first part is A plus B bar equals A bar dot B bar. Okay, shall I apply principle of duality here? Then we can write it this way. The A is there, B is there, and all these things are there, and A bar, B bar. Now we have to change this plus. We have to change this plus. We have to replace this plus by dot. We have to replace this dot by plus. Then what is this? This is first part of De Morgan's theorem. And when you apply principle of duality here, we have received second part of De Morgan's theorem. Okay. You can apply this one for any kind of theorem. It doesn't matter. Okay, next one. Logic identities. What about that if you take A double bar? What is A double bar? What is A double bar? Can anyone answer this question? What is A double bar? A. Yes. Yeah, good. It's A. Okay. Then likewise, can you try this one also? What is A plus A? Try to find this one. What is A plus A bar? And A plus 1. A plus 0. Can you find this one? And actually, what is the meaning of this one? What is A? How can we take A plus 1? This is A. We have given permanent 1 here. Then find this one. What is A plus A? We have combined both terminals together. Then if this is A, here also A, here also A. Then we have to find output. Okay. Then this is for operation. Shall we find the same thing for AND operation also? A dot A. A dot A bar. A dot 1. A dot 0. Okay, then this is A plus A. A plus A is A. A plus A bar. This is 1. This is 1. This is A. A dot A. A. A dot A bar. It's 0. This is A. This is 0. Okay. Then check it with your answers. If you have different answers, then let me know, then we can discuss it. Check it.
Excuse me, sir. Excuse me, sir.
Sorry that I was muted. Okay.
Sir, can you explain third one? How you get one?
This one.
Yes, sir.
Okay. Actually, that here, this one. And you have given A here. Then after that, this is the way that here this one is A, this is A bar. Okay. Then assume that this A is 0 at the moment. If A is 0, what is this? Then this is 1. Sorry, A is 1. This is A is 1 and this A bar is 0. Then because here we have 1, output is 1. Okay. Then shall we think that now A is 0? Because of this A is 0, this line is 0. Then because of A is 0, A bar is 1. Then again we have 1. Then output is 1. Then always whatever the value that A is having, it doesn't matter. When A is 1, output is 1. When A is 0, output is 1. Then whatever the value A is having, it doesn't matter. Always output is 1.
Thank you, sir.
Welcome. Okay. Anyone else? Okay, with this one, then what can we do? That now we have learned many theorems and laws here. Commutative law, associative, distributive, De Morgan's theorem, principle of duality, and logical identities. What is the purpose of learning these things? What is the purpose of adding these things to our list? Actually, now using these things, we can rearrange our equations. Shall we try it? Okay. For example, you may remember, I'll show you the this one, and this is the first. Okay, I think okay, now you can see my screen, and this is the first question you tried, and this is the first equation we had. First equation we tried. Okay, can I copy this one? Okay, this is the equation we had. Okay. It's coming from question 2. Now this is the equation we are having. Now we can rearrange this equation. How can we rearrange this equation? You can see here this A bar. Here also we are having A bar. Here C bar. This is C bar. We can take this A bar C bar out. Then inside we have B bar plus B plus, it's coming from these two terms. And when you consider these two terms, what is common? It's C is common. Then we can take C common. C out and A bar B, AB bar, they are inside. Okay. Then what is B bar plus B? You may remember that here A plus A bar is 1. Then B bar plus B is 1. What about this one? A bar B plus AB bar? Okay, we will find a solution for that one. You may remember the explosive OR gate truth table. This is exclusive OR gate truth table. We know that this is exclusive O between A and B. Okay. Then forget about this table is exclusive OR truth table. You can write output equation by considering these ones. By considering these ones, you can write output equation. Okay, for that, we can consider this one and this one. Then we can write output equation for F, that is A bar B plus AB bar. Okay, but what is F? From top, you know that this is A exclusive OR B. Then whenever the time you see that A bar B plus AB bar is there, instead of this part, straight away you can write this is exclusive O. Okay. Then new rearrange equation you can write. It's A bar C bar plus C A exclusive OB. Now you can compare. Okay, before that I have to tell something else also here. Okay. Here, can you look at this one? For zeros, if you write equation using these zeros, what is that? Well, actually we use this ones to write equation for F, but we didn't use zeros. Why? We are writing output equation for F. That's why we use ones. But if you consider F bar, then to write output equation for F bar, you have to consider zeros. Then this is A bar B bar and AB. Then you can write your new equation A bar B bar plus AB. That is for F bar. Then what is this? This is this. You know that this is exclusive no operation. Okay. Whenever the time you see this A bar B bar plus AB, straight away you can write this exclusive no between. Okay, can you hear me again? I think I had a small interruption. Can you hear me?
Yes, sir, we can hear you.
Okay. Then, okay, this is very important. You can remember this one. And you can write this one. And this is also very important. Okay, now you can go back to the equation. Now here, initially how many gates we had here? to make this bars, we need 3 NOT gates. Okay. Then to make this one, we need 4 AND gates and 1 OR gate to combine everything. Then 8 gates. Here, how many gates do we need here? 2 NOT gates. Okay. Then 1 exclusive OR gate and 2 AND gates and 1 OR gates. Altogether, we have 6 gates. We have reduced the number of gates. But what do you think about these 2 equations, this one and this one? Are they giving same functionality? Have we done anything wrong here? No, according to the laws and theorems, we haven't done anything wrong. Then, using all these things, we rearrange our equation. Then we found finally this one as the answer. Then function-wise, this one also should give the same result. But after rearranging this one, as a result, what we have received? Equation, this equation can be implemented using less number of gates. Okay. Then what do you think? And if this is first equation, and if this is second equation, what do you think? Which one is the best one? First one or second one?
Second one.
Second one. Yes, good. Why second one? We have used less number of gates. Because of that, we have used less number of gates. Our circuit cost is less. Is less. And because of that, we are using less number of gates. Our circuit size is small than previous. And because of that, we are using less number of gates. Our circuit power consumption is low. And many advantages are. Because of that, if it is possible, we have to rearrange this equation. But the technical name for this one is not rearranging equation. We say it's Boolean minimization. Boolean minimization of equations. Okay. Then to minimize any Boolean equation, we have 2 methods. One is using Boolean algebraic methods. Using Boolean algebra, we can minimize equations. That's what we have done here. We have rearranged this one using Boolean algebra. What is Boolean algebra? Those theorems and laws we have learned. That is Boolean algebra. Then using Boolean algebra means we can rearrange this equation using Boolean algebra. Okay, that is first method. The second method, using Kahneman method. Using Kahneman method. Actually, this is a complete different one compared to the previous. The first one is a kind of graphical representation of an equation. We'll learn this one later on. But first, we can consider using Boolean algebra. How can we minimize equations? Shall we we have tried 4 different equations there, the first section, and I have taken here the first question, the second question. You can try the third one